Hey everyone, welcome back to the channel. Some time ago I did a video on setting up a site-to-site VPN tunnel using Cloudflare WARP. Since then, Cloudflare has really streamlined the setup, making it easier and faster to configure. So today, I'm excited to walk you through the updated process. We'll cover everything step by step, starting with how to register for Cloudflare ZeroTrust service, installing the WARP client software, and connecting to the Cloudflare network. I'll walk you through the essential WARP modes and settings, touch on configuring DNS and firewall policies, and setting up routes. Finally, we'll dive into enabling the site-to-site connection using WARP connector as an alternative gateway. Let's dive right in to get your sites connected in no time. What are we trying to achieve? We have two private networks located in separate locations. One network with the address range 192.168.10/24 and another with the range 192.168.12/24. Within each network, we have a specific node that we'll use for testing. Client 1 with IP 192.168.10.232 in the first network, and client 2 with IP 192.168.12.232 in the second network. Our goal is to set up a site-to-site VPN, enabling secure seamless communication between remote networks over the public internet. This will allow client 1 in the first private network to communicate with client 2 in the second private network. Such setup is particularly useful for scenarios like connecting a branch office to access servers hosted in a main office, or connecting on-premise networks with the cloud environments. Typically, a site-to-site VPN requires public static IP addresses on both ends to establish a stable and reliable connection. However, there are some alternatives if you don't have a public static IP address or don't have access to the router or firewall. What we'll do to set up the connection is deploy a Linux server in each location. For this demo, I'm using node 1 with IP 192.168.10.231 and node 2 with IP 192.168.12.231, both running Ubuntu. We'll then install Cloudflare WARP software on both node 1 and node 2. These nodes will act as connectors, each creating a secure tunnel to the nearest Cloudflare data center. This setup allows us to route traffic between our networks through Cloudflare's infrastructure. This type of topology is known as hub and spoke. In our case, the nodes with WARP client software are the spokes, while Cloudflare serves as the central hub. Mind that in our demo, client nodes are not sending the traffic to the default gateway, but to a dedicated node on the same network that forwards the traffic to the remote network. First step is registering with Cloudflare. Mind that it's a different service than DNS, so you need to register one more time. Let's go to cloudflare.com and click Sign Up. I will select Zero Trust and Secure Access Services Edge, and then press Get Started with Free Plan. I will provide the email address and password for the super admin user, and then click Sign Up. Let's select the account. If you have other services like DNS, it will bind them together. Then you need to provide a team name. Your devices will then join that team. Moreover, your team name along with cloudflareaccess.com will form a domain where your users will find applications you have secured behind Cloudflare ZeroTrust, displayed in the app launcher. I will show you how that works in a different video. For this setup, let's provide Linux Cloud Hacks and click Next. Then let's select a free plan and proceed to payment. You will need to provide a payment method anyway, but you won't be billed. Let's finalize the purchase. Okay, done. You'll also get a verification email. I will copy the link and open it in the browser. Our email is now confirmed. Let's start by installing the WARP client software. I will go to ZeroTrust, Settings, and then Resources. Here are the WARP client installation versions for various operating systems. Mind that the site-to-site mode is only supported on Linux. Okay, let's proceed with the installation. To streamline the setup, I will perform the installation on two nodes simultaneously. Let's download the GPG key. Next, we'll add the Cloudflare repository. Finally, let's install the WARP client software. This will install a new service on our system. However, Our node is not yet connected to the Cloudflare network. To connect to Cloudflare network, let's navigate to Networks, Tunnels, and select Add a tunnel. Let's choose Warp connector as the tunnel type. I will name this tunnel Net10 to represent the network behind Node 1, though you can name it however you like. Then I will click Create Tunnel. Cloudflare provides installation instructions, but since we've already installed the software, I'll just copy the connection command displayed at the bottom and run it on Node 1. Then I will click Next and return to Tunnels. To confirm the connection to Cloudflare network, let's issue the following command. That's it, just a single command and we are in. WireGuard tunnel to Cloudflare network is up and running. Compared to past setup process, this approach is much simpler. Let's repeat these steps for Node 2. I will create a new tunnel, select Warp, name it Net12, copy the connection command and run it on Node 2. That's all it takes. Both nodes are now connected to Cloudflare network. In the Tunnels tab, we can see two healthy tunnels. With the tunnels established, let's explore the different Warp client modes. First, I will navigate to Settings, Warp Client, Device Settings, and select the default profile. Scrolling down, we see the available operation modes for Warp service. Let's start with Proxy Mode. I will set the port to 1080 TCP and save the profile. Now let's switch to Node 1, where our Warp client is running, and check that the changes were applied. This shows that the Warp client has started a SOCKS 5 server on port 1080 TCP. If we check our public IP, nothing changed. Now let's set the system to use the local SOCKS 5 proxy exposed by Cloudflare service. Let's run the IP check again. See the difference? Now our traffic is routed through Cloudflare infrastructure. Proxy Mode allows you to selectively route traffic through Cloudflare. You can configure specific applications to use SOCKS 5 proxy, directing only their traffic through Cloudflare's network while keeping other traffic unaffected. Next mode of operation is tunnel-only mode. To activate it, I will edit the connection profile, select Gateway without DNS filtering, and save the profile. To confirm the update, let's check the settings. Now, the mode is set to tunnel only. In this mode, all traffic except for the traffic on the excluded list is routed through the Cloudflare tunnel. Let's verify that by checking our public IP. Notice, our IP is now in the Cloudflare's IPv6 range. Let's also check our IPv4 address. As expected, our IPv4 address is also routed through the Cloudflare infrastructure. Behind the scenes, Cloudflare adds a specific routing rule to our system. This rule points the traffic to a custom routing table. All prefixes on this list are routed through Cloudflare. By going to Warp Profile, Split Tunnels, Manage, you can customize which IP addresses route through Cloudflare and which are excluded from the tunnel. By default, private IP address ranges are excluded and will route locally. You can also change the policy to only route specific networks through Cloudflare while routing everything else through the default gateway. Despite routing most traffic through Cloudflare, DNS resolution remains unaffected, and it's still handled by Google DNS. This is why it's called tunnel-only mode. You can route traffic through Cloudflare and apply firewall policies on that traffic, but DNS queries are resolved independently by client's chosen DNS service. The opposite of tunnel-only mode is DNS-only mode. In this mode, only DNS traffic is routed through Cloudflare, allowing enforcement of DNS policies, while all other network traffic bypasses Cloudflare's infrastructure. To enable DNS-only mode, let's go to Default Profile, Edit, and select Gateway with DNS over HTTPS and save the profile. Let's see if the change has been applied. Okay, the change is in place. Now let's verify our public IP. We can see the traffic is still using the default gateway. If we check the routing rules, the custom routing table is no longer present. However, there's now an additional DNS resolver running on the loopback interface. The system's DNS configuration points to this local resolver. Now, all DNS traffic is encrypted and routed through Cloudflare, allowing us to enforce DNS policies. To demonstrate, let's create a policy to block access to specific domains. I will go to Gateway, Firewall Policies, DNS, and add a new policy. As an example, I will block google.com. I will name the policy block.google.com, and in the traffic selector set the domain is google.com with the action block. Now let's test it by trying to resolve that domain. The DNS request is blocked. You can also block entire categories. For example, let's block all content categorized as movies. I will add a new policy named block movies, select content categories, movies, set the action to block, and create the policy. Now I will test another domain. The request is blocked. This feature is powerful for blocking access to malicious sites or inappropriate content, and it's especially useful in company setting to limit access to non-work related websites. As you might expect, the most powerful mode combines both tunnel mode and DNS mode, routing all network and DNS traffic through Cloudflare. To enable this combined mode, go to Settings, Warp Client, edit the default profile, select Gateway with Warp and save the profile. Let's confirm that this setting has been applied. Great, it's active. Now let's check our DNS configuration. The systemd resolve the stub resolver now points to the Cloudflare's resolver, and all traffic is routed through the Cloudflare tunnel. Using Warp with DNS filtering offers several benefits. It encrypts DNS queries to protect against man-in-the-middle attacks, enables filtering of malicious or unwanted sites, and routes traffic through Cloudflare's global network, reducing latency and improving speeds. This setup protects your browsing and data while allowing secure access to company resources or applications. This also allows us to set up a site-to-site connection so that devices on one private network can access devices in another location through Cloudflare infrastructure. Here are a few essential settings we need to adjust for site-to-site connection to work. By default, every WARP client is assigned the same private address, 172.16.2. I will navigate to ZeroTrust console, then Settings, Warp Client, and select Override Local Interface IP. These settings ensures that each Warp client receives a unique IP address from the CGNAT range 100.96/12. Node 1 is assigned the IP 100.96.0.13, and Node 2 is assigned the IP 100.96.0.14. Enabling override local interface IP is crucial for site-to-site connection to work at all. Now, let's test connectivity by pinging Node 2 from Node 1. It does not work. If we look at the routing to 100.96 network, it's still pointing to the default gateway rather than through the Cloudflare tunnel. To resolve this, let's go to Device Settings. While we could create a new profile, I will edit the default profile. Next, navigate to Split Tunnel section, which tells the WARP client which traffic should be routed through the tunnel and which should be excluded. I will click on Manage to see the list of network ranges excluded from the WARP tunnel. I will remove the 100.64/12 range from the list. By doing this, traffic to the 100.96 network will now be routed through Cloudflare. If we check the routing on Node 1 again, we should see it points to the tunnel. Let's try pinging the remote node again. It still does not work. To fix that, we need to go to Settings, then Network, then Firewall, and enable Proxy. This will forward the traffic to Cloudflare Gateway for policy enforcement. Ensure that you enable this for TCP, UDP, and ICMP protocols. Additionally, tick Allow Warp-to-Warp connection to enable communication between the two Warp devices. Now let's test the connection one more time. Success! We have peer-to-peer connectivity between the nodes. Before we dive deeper, let me show you something important. By default, all traffic is routed through the Cloudflare Gateway, a robust security solution that allows traffic filtering based on various policies. Initially, all traffic passing through the gateway is allowed. Let's test this with an SSH connection attempt from Node 1 to Node 2. We got a prompt, so the connection works. Now I will navigate to Gateway, go to Network, and click Add Network Policy. I will name the policy Block SSH, set the traffic type, and specify the protocol as TCP with destination port 22. I will set the action to block and then create the policy. Now let's try connecting to port 22 again. As expected, the connection is blocked. Cloudflare Gateway is highly versatile. It can filter not just by IP, protocol, and port, but also by application, country, and other parameters. You may have already seen some of the DNS filtering capabilities. There's also an HTTP mode, which even allows blocking specific file types. Note that inspecting HTTPS traffic requires enabling TLS decryption. Today's video isn't focused on firewall policies, but I wanted to highlight this feature as it's incredibly powerful. We'll cover it in depth another time. Alright, we have peer-to-peer connectivity. Now to enable site-to-site connectivity, we need to take a few additional steps. The first is enabling packet forwarding on both our nodes to allow traffic to pass between Cloudflare and our internal network. Let's start with node 1. On node 1, I will open the kernel configuration file, I will uncomment the packet forwarding line and save and apply the changes. Now, let's switch to node 2 and follow the same steps. I will open the configuration file. After enabling packet forwarding here, I will apply the configuration. With packet forwarding enabled on both nodes, the next step is to set up routing in Cloudflare. We'll configure it to send traffic for the 192.168.10/24 network through node 1 and traffic for the 192.168.12/24 network through node 2. To do this, I will go to Networks, select Routes and click Add a route. For the first route, I will specify the traffic to the 10 network should be sent via the net10 tunnel pointing to node 1. After creating that route, I will add another route for the 12 network via net12 tunnel that points to node 2. With this route in place, Cloudflare should know how to direct the traffic to our private networks. Let's test the configuration by trying to ping client 2, a host on remote private network from node 1. Ping fails. We need to investigate the routing. I will check the route to client 2. It seems the route is defaulting to the primary gateway instead of the Cloudflare network. This could be an issue with the split tunnel configuration. Let's go into WARP client, edit the default profile, and manage the split tunnel settings. It appears that the entire 192.168/16 network is excluded from routing through Cloudflare. I will remove this exclusion. Now, if we check the route again, we see that it's now directed to Cloudflare. Let's try to reach client 2 again from node 1. It does not work. Let me trace the route. The trace shows that the traffic enters the Cloudflare network and reaches node 2, which is our remote Cloudflare endpoint. However, it stops there. Let's go to client 2 and start a traffic capture to monitor incoming ICMP requests. Now, I will initiate a ping from node 1 to client 2. Let's check the capture on client 2. We can see that client 2 is receiving the ICMP echo requests and sending a reply. So why isn't the connection working? Let's examine the route from client 2 to the 100.96 network, which is where the traffic is originated. Here's the issue. Client 2 is sending the response to the default gateway instead of routing it back to node 2, which needs to send it to Cloudflare. There are a few ways to resolve it. We could make node 2 the default gateway for this network, which would ensure all traffic from client 2 routes through node 2. Another option is to perform NAT on node 2 for traffic directed towards the local network. However, for this setup, let's add a static route on client 2 that directs traffic bound for the 100.96 network to node 2 instead of the default gateway. Now, if we check back on node 1, the connection should be working. Remember, if the Cloudflare connected node isn't the default gateway, you will need to add a specific route on the client devices or the gateway itself to direct traffic to the Cloudflare node for the remote network access. Next, let's configure client 1 with the necessary routes to reach the remote network via node 1. On client 2, I will add a route to reach the 192.168.10 network via node 2. The route to the 100.96 network is already in place, so everything should be configured. Let's run a final test by tracing path from client 1 to client 2. Do you see that? The traffic first goes to node 1 thanks to our static route instead of the default gateway. Then it enters the Cloudflare network since we excluded the 192.168 network from local routing in our split tunnel configuration. Cloudflare knows to route this traffic to node 2 as we specified it in the Cloudflare GUI. Node 2 then directs the traffic to client 2 on its local network. Client 2, with its static route in place, sends the reply back to node 2, which then routes it through Cloudflare back to node 1 and finally to client 1. Thanks for following along with me through this updated Cloudflare WARP setup. We've covered a lot, from registration and installation to configuring site-to-site tunnels, different operating modes, and even enforcing firewall policies. With this simplified setup, connecting remote networks securely over the internet has never been easier. If you found this video helpful, please give it a thumbs up and subscribe for more hands-on networking tutorials. Don't forget to hit the notification bell so you don't miss our next video where I'll show you how to use the Cloudflare connector to implement a zero trust policy in your company. Thanks again for watching and I'll see you in the next one.